In this video, we're going to be looking at a couple special derivatives here. So it's really just going to come down to committing these to memory. There isn't too much conceptually going on. You're just going to have to remember these. So we're going to start off with the derivative of our sine and cosine functions. The derivative, which we can write as d dx, d dx, the derivative of our cosine function, cosine of x, is simply going to be equal to negative sine x. Negative sine of x. This is going to be the derivative of cosine x. And the derivative of sine x, d dx, of our sine x here, that's going to be cosine x. But it's positive here. So you can see the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. So we just have to commit these to memory. So if, for example, we were given a function and we want to find its derivative, let's involving the sine and cosine, let's see what that would look like. So we have our function 5 sine x minus 3 cosine x. What is the derivative? Our f prime of x here, what we'll have to do is, first we just bring down the 5. So in the derivative of our sine x here, right? We know the derivative of sine x is cosine x. So 5 cosine x minus 3 times the derivative of cosine we know is negative sine. So if we simplify this a little more by distributing our negative, we can see that we get the derivative of this function to be 5 cosine x plus 3 sine x. 3 sine x. So this is going to be our answer here. So this is our answer. So again, it just comes down to memorizing these here. I know, remember we had to memorize a couple special limits earlier before as well, like the limit as x approaches 0 of our sine x over x, and a couple others there. So, we just have to memorize these as well, and then when they come up, you can just simply implement them. All right, now let's look at some special, derivatives of exponential functions. So if we're given an exponential function, right, and we're trying to find its derivative, let's say we're trying to find the derivative of any exponential function, right, some number raised to the x, well, that derivative is simply going to come out, oops, 1 second, going to come out to our number a to the x multiplied by ln, that is the natural log of our base here, of a. So for example, if we had 3 to the x, the derivative would be 3 to the x times ln of our base here, which is 3. So now, keeping this in mind, what if we're looking at something like the derivative of e to the x? So this e is a number like this, and it's raised to the power of x. So how do we use this rule? Well, we can see that we would just get e to the x times ln of our base here, which is e. But we know that ln of e is just 1. We know that ln of e is just 1. And so that gives us a very special little thing that we notice here, is that the derivative of e to the x is just e to the x. So that there is really easy. So if we ever see they're taking the derivative of e to the x, that would just be e to the x. And again, that's also, we can see how we get that. We're using this same rule of exponential functions. It's just that the ln of our base happens to cancel out and equal 1, leaving it with just the original function. But in any other case, we do the original function times ln of that base. So let's look at an example. So if we're looking at a function f of x, which is 9 to the x plus 4 times e to the x, what is the derivative here? Our f prime of x, the derivative of this function, is we just use this rule here. First we find the derivative of this first term and we add it to the derivative of the second one. So the derivative of 9 to the x is just going to be 9 to the x times ln of 9. 9 to the x times ln of 9. And then we take the derivative of the second part. we know that the derivative we know that the derivative of e to the x is just going to be e to the x. And because of that, we can just say that our answer here, sorry, my cursor seems to be glitching. So our answer would then just be 4 times e to the x. So again, if we just wanted to write this as 9 to the x, ln 9 plus 4 e to the x. This would be our derivative. This is a 9 here. So yeah, just another important thing to keep in mind with the derivatives. So whenever we see our exponents there, we can use this little trick. Now that we've looked at exponential functions, the next step is logarithmic functions. So looking at the derivatives of logarithmic functions, there's another baseline little formula here to look and kind of commit to your memory. So we're taking the derivative d dx of any logarithm, some log with, again, base a, whatever that base may be, log base 10, log base e, if we're looking at the natural logarithm, again, of some x. That derivative is just going to be equal to 1 over x times 1 over ln a. So our x here, again, is the original, and then the ln of our a. The a is the base of the logarithm. So this is going to be something we have to commit to memory once again. And so looking again, then if we were looking at the natural log as we did last time in this case, ln natural log of x, this is our derivative. Well then, if we want to use this rule, well, we know that the natural log of x is just log base e, right? That's log base e of x. So if we're taking the derivative of log base e of x, writing it out in this way, that's just going to be 1 over x times 1 over ln of our base. So 1 over ln, the base here for a natural logarithm is e. And once again, we know that ln of e is just 1. So 1 over x times 1 over 1 leaves us with just 1 over x. So the derivative of the natural log of x is just going to be 1 over x. So this is again something that may seem a bit tricky at first here, but I promise you're going to be using this a lot, and so it'll kind of just become very simple and you'll just commit it to memory as you just do more problems. So then let's look at an example where we get to use these derivatives of logarithmic functions. So if we're told that we have a function log base 3 of x minus 7 ln of x. What is the derivative here? Well, if you can remember our f prime of x, our derivative here, if we're using the logarithm rules that we just learned, first we'll start with the log base 3 term, and then we can go on to the ln term. So remember, this is going to be 1 over x times, let me make it a bit smaller, that's going to be 1 over x times ln, or rather times 1 over ln of our base, which is 3. You can see that this we can already just rewrite as 1 over x ln 3, and then we can move on to the next part. We know that the logarithm, or the derivative of our natural log is just 1 over x. So this is 7 times 1 over x. We can rewrite that to just be 7 over x. So this is going to be our derivative here. We're just using, again, the tools that we just learned. Nothing too complicated. Alright, using these tools that we learned in this video, we're able to find the derivatives of a lot more different functions. You'll notice that different functions will just include combinations of these different components, whether it be including our trig functions like our sine and our cosine, but plus also including some of our exponential functions, or if we have something like an exponent plus log base 3 of x, again, we know how to deal with this and we know how to deal with this. We just have to put them together when we're taking our derivatives. Same thing over here. So it's really just going to be remembering these different, these different derivatives there, and applying them in each of these scenarios where we're combining different things together. But that brings us to the end of this video. Hopefully you found it useful and you learned a thing or two. If you did, please show your support by liking and subscribing. Leave in the comments any questions you may have, what you'd like to see for future videos, and I'll see you in the next one.